Hello everyone, welcome back to another lecture. So we are solving the West Bengal set papers of 2025, that is 27th of 20 WB set exam. Fine, and we already covered three lectures of solving of the WB set exam, and we already covered most of the cases like linear algebra, complex analysis, then the ODE, I think ODE we cover PDE, and then uh, linear integral equation, then calculus of variation, and numerical analysis. We already covered most of the things, okay? Then classical mechanics and so on. So I think 9 to 10 topics already we covered. I forget those things. So in today's lecture, we will cover actually the linear programming problem, LPP, and then number two is Fourier transformation. Okay, two questions comes in Fourier transformation from Fourier transformation actually, and in this year I think 4 or 5 questions comes from LPP. So LPP is very important nowadays for preparing the WB set paper. Okay, and also there were I think two questions that comes from Fourier transformation and one question we solve from I think it's the from the differential calculus, one from differential calculus. Fine. So let's solve this problem, and before starting I'll request to you all, those who are watching my channel for the first time, so don't forget to subscribe the channel because nowadays I will show that I have showed that most of you are watching my videos, watching but not subscribing. So this is very bad behavior, not subscribing. So please do subscribe the channel, because to make one video it's very hard work in the background. I think those who are preparing some content in online, you may definitely consider this. So let's start, and definitely subscribe the channel, do subscribe the channel, okay? Because one subscription give me very much level of motivation. So let's solve this video. This video is from the LPB question number 20 is, and all the questions are from X series. So it says that both the transformation and assignment problems are numbers of category of linear programming problem called the. So we know that this transportation problem and assignment problem are well known as traveling salesman problem, right? Traveling salesman. Traveling salesman problem, which is so shipping problem. We cannot say that this is only shipping problem. Yes, this is kind of shipping problem. Shipping means suppose online delivery like Amazon, Flipkart. Okay, so they have a warehouse and they give the delivery of your parcel at your doorstep. So they find they are obviously use, they may definitely use the LPP in background, but an ordinary delivery man, yeah, I think he is not aware of this. So not only shipping problem is the transportation and assignment problem, because here both the uh, cases, that is both the problems of LPP have considered here, which is transportation and assignment. So both the problems are not the cases of shipping problem. So most likely these two problems are the problems of network flow. Okay. So option C here is the answer. Routing problem, one kind of routing problem. Traveling salesman obviously kind of routing problem, but for both the problem, this is not true. Okay, for a single problem, like if the question says that only transportation problem, then it may be right, this option B and D. But here you have to consider generalized case of the assignment and the transportation problem, and generalized flow problem, no. This is no flow problem, is a different problem. Okay. So the most correct answer, not most correct, correct answer is option C, network problem. So this is a theoretical and more you can say that general knowledge based question. Okay. So if you have some knowledge based question, you can say, if you have some basic knowledge on the LPP, then you can definitely answer if you understood that transportation problem and assignment problem. Otherwise this is a little bit difficult to solve. Next question says that it is question number uh, 29. If a linear programming problem admits an optimal solution, then the optimal solution will be coincide with at least one word. So feasible solution, basic feasible solution, basic feasible solution, non-basic and basic feasible solution. So to solve this problem, you have to understand that how the solution of a LPP develop. Fine. How solution develop in the background. So if you are not aware of the development of solution procedure of LPV, then I'll recommend that please watch my lecture. Okay, I have already made one lecture series on LPP for GATE exam, SET exam, or CSR NET exam. So in that lecture series, the second video contains some definition. Second video, okay. Second video or lecture contains in my playlist. In my channel, you get my playlist. You will definitely get my playlist of LPP, right? So you can watch this lecture one by one. Then I must say that you can definitely solve any problems of LPP after watching my lecture, because I'm a guest perspective. From GATE perspective, I have made that playlist, so you can definitely solve that. So how actually the solution of LPP develop? So first we consider, or first we take a feasible solution. Okay, feasible solution. Feasible means what? Non-zero solution. Okay, feasible means yeah, no, matlab non-negativity means non-negativity. Okay, non-negativity in the solution, that is non-negativity. That is, we write for like any LPP x1, x2, like these two are the variables are obviously greater than 0. So this defines the feasibility conditions actually. In any LPP, you say that this condition is written in the problem. So feasible solution. So only feasible solution does not imply the optimal solution. Now basic solution. What is basic solution? You have to understood that if we have a system like Ax equal to B, and A is a matrix of m by n, where this m and n are not equal, then what we do? We put the first some m variable, suppose n minus m variable. Suppose if B is vector of n by 1, then we have to actually uh, arrange this matrix so that this matrix should be an m greater than n. This matrix should be n by n order. Okay, so we put this some n minus m or m minus m variable, or n minus m variable, whichever is greater than, so that variables are 0. Okay, then because this is an over determined system, we cannot solve a sorry, under determined system, because the number of unknowns is greater than the number of equations, so that we have to put some variables 0 and the remainings are non-zero. So we say that these non-zero variables as the basic variables, and the zero with variables are the non-basic variables. Actually these non-basic variables lead to a solution which also satisfied the non-negativity conditions, x is greater equal to 0. So that means what happens here is that we need an basic solution as well as feasible solution that obviously identify an optimal solution. So for an optimal solution, for we can say that for a solution to be optimal, For a solution to be optimal, and uh, it must satisfies it must satisfies the feasibility condition, feasibility condition as well as the non basic condition, or the variable should be basic. Okay, basic variable or basic solution, you can say the solution is said to be basic solution. So which option is true? Option C is true. You have to understand the development of solution, then you can easily solve this problem. Okay, next question, question number 13 X series comes from game theory. See, generally the question doesn't ask from didn't ask from game theory in the previous years, but in this paper one questions comes from the game theory perspective. Okay, so we all know that the games theory is dependent on the min max theorem, or max min theorem, you can say. So in case of game theory, there is a general theory which is that min max is less equal to max min. So this is a very famous theory. I am not sharing the statement here, but you just remember that, or remind that for the for this matrix to be a game, it should max min condition is equal to min max condition. Okay, max min equal to min max, and this should be the value of the game, which is given here 5. Now we calculate what is the max min. Suppose we first consider the rows. Okay, so minimum of the first row is 6 and 1. This is equal to 1, and minimum of second row is x and 5. So maximum of these two minimum gives the max min. So this is 1 and x, sorry, 1 and minimum of x and 5, minimum of x and 5. This is one thing, and another one thing is that now we consider the case column which gives us the min max. Okay, so maximum of 6 and x, this is one thing, and maximum of 1 comma 5, this is equal to 5. So minimum of this 5 and maximum of this 6 and x. So these two things, this thing and this thing, should be equal. Now what is the value of x? You have to find so that they are equal. Now we consider the options one by one. Option A is 0. If this is 0, okay, this x is 0, then maximum of 1 and 0 is 1. This should be 1. If we consider x equal to 0, then the maximum value is what? Maximum value is 1. 1 and this minimum value of this 0, this 0. Okay, that means this is finally 1, the max min value, and the min max value is, if we consider 0, then 6 is the maximum here. Therefore minimum of this 5 and 6 gives you 5. So this is 1, this is 5, they are not equal. That means option A is incorrect. Now if we consider 1 as the value of x, then what will happen? Then if we put here x equal to 1, then minimum of this 1 and minimum of 1 and 5 is 1, and maximum of 1 and 1 is again 1. And here what happened? Maximum of 6 and 1, this is 6, and minimum of this again 5. So here 5, here 1. These are unequal. That means option B is also incorrect. Then if we write option 3, that is 3. If x is 3, then minimum of 3, 5 is 3, and maximum of 1 and 3 is 3. And here 6 and x maximum is 6, minimum of 5 and 6 is 6. Minimum is 5. So this option is also incorrect. Therefore, option D is clearly the correct answer. You can also check. How can you check that? See, if we put here 5, so minimum of 5 and 5 is 5, and maximum of 1 is 1 and 5 is 5. And here also, if we put C 5 here, so 5 and maximum of 6, and this minimum is again 5. So 5 and 5, these two are matched. That means option D is correct answer in this case. Next question. It says that for a linear programming problem, z equal to this, subject to this, we have this. So simply we can draw the graphs by putting these two constant. So the constant are 2x1 plus x2 less equal to 6. If we convert this, then this 6. And we can write this is x1 by 3 plus x2 by 6. This is equal to 1. And the second one is x1 minus x2 is equal to 3. The equation format. Okay. So now if we put x1 and x2 here, so x1 and x2 say. So suppose only there are two constant 2 and 3 and 6. So suppose this is 3, this is 6, this is 3, this is 6, this is 3 unit, means 3 minus 3 and so on. So here the point is 3 0 0 3 0 6. So this is the curve for the first case, for the first equation, and if we put the 0 0, then this satisfies. That means the region is in this side. Now the second one is uh, x1 by 3 minus x2 by 3 is equal to 1. So 3 0 and minus 3 0 are the point. So 3 0 in this point, minus 3 0 is this point. So this is the graph. Okay. And if we put 0 0, then this does not satisfy. That means the region is opposite to the center. So we get only one common point, and the point is 3 0. Fine. And since this is an extreme point, fine, this is an extreme point. So we get one point in which these two curve cuts actually each other, intersect each other. So that means 3 0 we get one solution. Fine. Otherwise we cannot find any solution. So that means 3 0 is a solution, and this satisfies all the conditions. You can also check by putting this into the LPP. So we get one solution which is an optimal solution. Option A is true in this question. Now this question is from Fourier transformation. Let the function xt satisfies the x double dash t, x double dash plus 2x dash plus 2x. This is equal to 0, x0 equal to 1, x dash 0 equal to minus 1. So if we take the Laplace transformation, taking Laplace transformation, we get L of x double dash plus 2 L of x dash plus 2 L of x. This is equal to 0. Now we know that what is the Laplace transformation of first case. L of x double dash, this is equal to, suppose the Laplace transformation xt goes to capital X in the variable x, then this gives, we all know that s square xs minus s what x0 x0 minus x dash 0, which is equal to s square xs minus s plus 1, I think. Yes, minus s plus 1. And L of x dash is equal to s xs minus x0. This is gives x xs minus x0 value is 1. So if we put these two things to here in this equation, then we get what? We will get s square x minus s plus 1 plus 2 sx minus 2 plus 2x. This is equal to 0. So if we take x common, then s square plus 2s plus 2 into x, and s 2 and this 2 come, this is equal to s plus 1. That means x of s, this is equal to s plus 1 by s square plus 2s plus 2. This can be written as s plus 1 by s plus 1 whole square plus 1, which is your required answer, option B. Fine, just you have to take the Laplace transformation. There is nothing to do in this problem. Fine, next question. It says that it's a basic question. The Fourier transformation of a real and even function yields purely A. So first define the Laplace transformation for any function small t. The Laplace transformation is defined by minus infinity to infinity ft e to the power minus I omega t dt, if omega is the transformed variable. Now it says that the function is real and even function. That means these functions f of minus t equal to ft. Fine. This is the even function and real. So if we break this exponential term, then fs can be written as minus infinity to infinity ft cos omega t dt minus iota integration infinity to infinity ft sine omega t dt, because we all know that e to the power ix, if we take this is cos x minus iota sine x, just we break this. Okay, now ft is even function, but we know that the sine function is an odd function, and product of even and odd, even function into odd function, this is equal to clearly a odd function. That means this whole function is an odd function. That means what happened? Integration minus infinity to infinity function in this integral is 0. So we only have integration minus infinity to infinity ft cos omega t dt. See, f is even, cos is also even function. We know that multiplication of even function and even function is an even function. Fine. So this is even clearly. So that means here it says that odd, here it odd. Now also you can see that this imaginary part goes to 0, and this, in this part there is no uh, imaginary portion, because already imaginary portion is 0. Therefore imaginary also not the correct one. Therefore real and imaginary. So this is clearly real and sorry, even function and real function. Okay, so this is the last question for today's lecture. In the in the upcoming lecture we will cover the abstract algebra portion. Okay, so in this lecture this is the last question. A circular helix is, what is the circular helix? I think this is a question from differential calculus. Okay, so what is the definition? So definition is a circular helix is a space curve that has constant non-zero radius of curvature and constant non-zero torsion. Now what these two term means? And one more thing is that the circular helix is most commonly written as r equal to a cos t plus a sin t plus bt. Fine. This is the most common equation, and radius of curvature is given by kappa is equal to a by a square plus b square. So clearly say that this is a constant, and constant non-zero torsion. This means actually this represent a twisted curve. Twisted curve, which means this circular helix does not lie in a single plane. Fine. So that means this is not a planar curve. Fine. First answer is planar curve. No, because this does not lie in a single plane. Twisted curve. Yes, this is answer. Curve of constant curvature. This is also correct. But and the D option is not related to this question. So the option most probably B and C, but I check the answer, only B is given. I don't know whether this is any other case or not. But in this case, na, both B and C are the answer, because in the definition it says that non-zero radius of constant curvature. Okay, constant curvature. But yeah, you can discard option C by only saying that this non-zero term is not given in this option C. Therefore, it can we discard this thing. So option B is the answer. Okay, twisted curve means that has non-zero torsion. So option B is the answer, we can say, because of non-zero term is not given in C, because this is a constant non-zero radius of curvature. Because and if the radius of curvature is 0, then 0 is also a constant, but 0 is not considered in the definition of circular helix. Okay, so that means option B is our answer. So in the next video we will discuss the questions from abstract algebra. Fine. So stay tuned for that. And if this video is helpful for you, then definitely let me know in the comment section below. And those who are not subscribing my channel till now, please do subscribe the channel. It will be very beneficial for me to make the videos. Okay, thank you.